Hello, Algebra 2 kids. I thought I would start off today with a light note for you, just a little bit of a joke, and ask, how do you keep warm in a cold room? You go to the corner because it's always 90 degrees. Okay, just joking around with you, but let's get started here. We are going to be starting chapter 7 today, and the very first thing that we are going to look at is the difference between direct variation and inverse variation. Both of those things are things that as you look at the words you might not understand what they mean, but hopefully here in the next 15 minutes or so, you will get a better idea of what the difference is between direct variation is by looking at equations and by tables of values. So basically, direct variation is a linear function, where as x increases, y also increases. They vary directly. And or if x decreases, y also decreases. Okay, and inverse variation, they vary inversely, which means they're going in opposite directions. So as x goes up, y is going to go down, and vice versa. If x is going down, y is going to be going up. So let's take a look a little bit deeper into what that means. Okay, so direct variation, it's a relationship when the value of x varies. X goes up, y goes up. X goes down, y goes down. And you can kind of read through here and see it's a linear equation. And if you remember anything about linear equations, we usually think of slope-intercept form. So when we're talking about direct variation, it's basically like looking at an equation, a linear equation in slope-intercept form, but there's no y-intercept. That's basically what it means. So your y-intercept is essentially 0, so you're always going to pass through the point 0, 0. An example of that would be when you buy something. So here I have an example where it says you're buying pop, okay? And when you're buying the pop, okay, the cans of pop cost $1.50 each, okay? The amount you spend, which is y, varies directly on how much pop you buy, which is x. Okay, so as if you think about it logically, the more pop that you buy, the more money you're going to spend. As x goes up, y goes up. And if you look at this, the way the equation looks here, we have our equation would be y equals a times x, where a is a constant of variation. And generally speaking, when we're talking about a constant of variation like this, it's basically like slope, okay? Because if you look at it, y equals ax. Well, if we were talking about slope-intercept form, we would call that y equals mx, right? Slope is m. In this case, with a direct variation, a is basically like slope. And if you look down here, where it talks about what a equals the ratio y over x. And if you think back to what slope was, slope back in Algebra 1 and earlier in this class also, was the change in y over the change in x. Okay, so essentially your a value with direct variation is just like your slope. And if you notice when you have direct variation, it's y equals a times x. Kind of like plus 0 on the end, but we don't actually put that there. So direct variation looks like a linear equation, y equals a times x, where a is essentially like the slope. Now, what I would like for you to do is just outside my classroom door, around the corner, kind of by the pop machine there is a piece of paper hanging on the wall that says direct variation and your class period, and it says real life examples. I want you to pause the video, get up, go out in the hallway, find a spot on that piece of paper that has direct variation with your class period on it, and write a real life example. Kind of like I have the cans of pop. The more pop you buy, the more money you spend. Something like that. Come up with your own, not exactly like that, example that would be a real life example of where you might see direct variation. Okay, so pause it, go out in the hall, and then come back in and start your video again. Okay, then we have inverse variation. Inverse variation, the values vary inversely, which means as one goes up, the other goes down. So like a real life example of that would be the grade you earn on a test and the amount of time you spend messing around in class, i.e., the more you mess around, that's going up, the less your grade will be. So it's varying inversely because you are doing more of one thing and getting less of something else. Okay? Or another example would be like the relationship between the time it takes to build a playground and the amount of people helping build it. The more people you have, as the number of people goes up, the time it takes goes down. So those are things that vary inversely. Algebraically speaking, this is not a linear equation. Okay? If you notice, it is y equals a divided by x. X is in the denominator. A is not going to be like a slope or anything like that. The graph of it, which we will look at later, is not going to be linear. A is called a constant of variation, okay? And the constant of variation is a relationship such that A equals x times y. So remember, direct variation was A equaled y divided by x. Inverse is A equals x times y. Okay, so you can't, and a lot of times kids get these two things confused. When you have it solved for y with inverse variation, your x is in the denominator. When you have a solved for a, it's x times y. So you just have to kind of work your way through as we do these examples and help you to remember which one's which. Okay, so now that we've kind of gone through what inverse variation is and examples of what it is in real life that you could use, I want you to do the same thing you did with direct variation. I want you to pause the video and go out, find the piece of paper that says inverse variation and your class period, and write an example in real life, kind of like the grade and the messing around or the playground and the time. Think of something in real life where something varies inversely, like just like you thought of something in real life for direct variation. Then come back in, start the video on the next slide. Okay, so the next thing we're going to look at is if I am just given an equation, how can I tell if it represents direct variation, inverse variation, or neither? And the important thing to remember here is first thing you want to do, just like anytime we write an equation, we usually have y all by itself. Same thing. Solve for y first. So we want to have y equals something. So that's the first thing we're going to do. And just a little comparison here. Direct variation means you have y equals a times x. It's like you have a slope multiplied times x. A can be a fraction, it can be a decimal, it can be a whole number, it can be positive, it can be negative, as long as the x is in the numerator and it's just being multiplied by a. Okay. Inverse variation over here is y equals a divided by x, which means you're dividing by x instead of multiplying by it. X is in the denominator, and again, a can be positive, negative, fraction, or decimal. And sometimes, let's be honest, it's not direct or inverse. It might be neither, which means you have something where you have two terms being added together, like maybe y equals 3x plus 5. That's definitely linear, but it is not direct variation because we have that y-intercept that's not 0. Okay, so what we're going to look at here is we're just going to look at the equations and say, is this direct variation, inverse variation, or neither? And just like it says here, first thing that we do is we get y all by itself. So if I have x times y equals 5, first thing I'm going to do is divide x on both sides. And I get y equals 5 divided by x. And as I'm looking at that, I say, okay, I've got dividing by x, and if I am dividing by x, that tells me I have an inverse variation. Okay, this next one, letter B, y equals x minus 4. That's definitely linear, no doubt about it. If we graph that, it would make a line. However, it is not direct variation because we have this minus 4, which tells us it does not go through the origin at 0, 0. So this one would actually be neither. Okay. And this last one, again, we want to get y all by itself first. So I'm just going to multiply both sides by 2. And I get y equals 2 times x. That's definitely linear. I've got a slope of 2, or my a value in this case is 2. So I would have this one is direct. All right, now you go ahead and try it. There's 3 here. I want you to make sure it's solved for y first. Think about if that means it's direct or inverse. Get these 3 done, and then pause the video, come check in with Mrs. Kreifel so she can check that you're done. Okay, now we're going to look at what if it is not an equation, but what if it's a table of values. Okay, so again, we've got our 2 comparisons here. We've got our direct variation and our inverse variation. I'm not being able to zoom in here. There we go. Okay, so the question is, how do I know if it's direct, inverse, or neither if I'm given a table of values? Okay, so to do this, we need to look at the constant of variation. Remember, the constant of variation is our a value. Okay, so our constant of variation is our value of a. Okay, so in this case, we want to get x and y on the same side of the equation. We want to solve for a. We want to solve for that value that's comparing your x and your y. Okay, so you have, if it's direct variation, remember that's y equals a times x. I'm just going to divide both sides by x, so I get a equals y divided by x. I'm going to show you what I did here. So I wanted a by itself, so I just divided both sides by x, and I got a equals y divided by x. Okay, and on the other side, I have inverse variation. When we have y all by itself, that means that we have y equals a divided by x, and I need to multiply to get a by itself, so I'd have a equals x times y. Okay, so if you're looking at a table of values and you have a constant a value that is y divided by x, that means it's direct. If you have a constant value when you multiply them together, that means it's inverse. And of course, there's always if it's not constant each time, it's neither. So let's look here at our tables, okay? So remember we said if it was direct variation, that means if you divide y divided by x, you should get the same thing every time. So I'm going to put up here y divided by x, right? That would mean, I'm just going to add to my table, that would mean it's direct. Okay, so if I divide y divided by x, negative 12 divided by 2 is negative 6. Negative 6 divided by 4 is negative 3/2. Negative 4 divided by 6 is negative 2/3. And negative 3 divided by 8 is negative 3/8. That is definitely not constant. It is different every time, so it is not direct variation. Okay, so down below here, I'm going to think a little bit. I'm just going to add to my table and think about if it is inverse variation. Okay, inverse variation means it's going to be the same every time if I multiply x times y. So if I multiply x times y, negative 12 times 2 is negative 24. Negative 6 times 4 is negative 24. Negative 4 times 6 is negative 24. And negative 8 times 3 is negative 24. These are all the same. My constant of variation is the same each time, which means x times y is the same each time, so it is inverse variation. Okay, so if we look over here, I'm just going to kind of put that same chart on here. I'm going to go up, and if it is direct, I'm going to use a D for direct. That means y divided by x is the same thing every time. If it's inverse, if it's inverse, that means x times y is the same thing each time. So let's look back up here at the top. Y divided by x. Well, 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 3, it's not 2, that's 8/3. 16 divided by 4 is 4. That is not constant. It's not the same every time, so it is not direct. In order for it to be direct variation, it would have had to have been the same thing, 2, 2, 2, 2. So let's check and see if it's inverse. Okay, inverse means that x times y will be the same every time. Well, if we multiply 2 times 1, we get 2. 4 times 2, that's 8. 8 times 3 is 24. 16 times 4 is 64. That is not constant. That's not the same every time, which means it's not inverse either. So if it's not direct and it's not inverse, that means that it is neither. Okay, and now, again, I want you to try it. And then once you get these two done, I want to see if it is direct, inverse, or neither. And please have some work that shows me how you either, added to your chart to show direct and inverse, or have some work down here somewhere that shows that you know what that constant of variation is each time. I find it easier to put it up into the chart so you can kind of see it and label it a little bit better. Okay, the last thing that we're going to do today is actually write some equations and then evaluate them, okay? And most of the time, you've spent in Algebra 1 and geometry, you spent a lot of time in the linear equation world. You did a lot of linear equations, slope-intercept form, all that kind of stuff. And that was direct variation, okay? Direct variation is linear. We are actually moving forward in this chapter, going to spend more time with inverse variation. So what we're going to talk about now is some ways to write an equation if your variables vary inversely, okay? So the way it'll look, it will tell you that they vary inversely, and then it'll give you values of x and y. Okay, so kind of step by step here what you do. Step 1 is you write an equation that relates x and y. Okay, that means you substitute the given values and solve for a. All right, so what I need to do is figure out what my a value is. I need to figure out what my constant of variation is. Well, I know they told me y is 4 and x equals 3. So if I use this formula and I just say, okay, I'm going to take out y and I'm going to put 4 in its place. I'm going to take out x and put 3 in its place. I have 4 equals a over 3. I want to know what a is, so I'm going to multiply both sides by 3, and I get a equals 12. That means my equation, okay, for my inverse variation that I can write is y equals, right, a over x. Well, I just said a is 12, so 12 over x. So here's my equation. So now that I know that they vary inversely, and my a value, my inverse is going to be 12, I can write my equation. And then the last thing it says is find y when x equals negative 2. Well, all right, I know what y is when x equals 3 because that's up here. They told me that x is 3 when y is 4, but I want to know when x equals negative 2. So all I have to do is substitute my negative 2 in there, and I get y equals 12 divided by negative 2, or y equals negative 6. So if I was going to kind of have some kind of table of values, or I was going to graph this, I would have the ordered pair. I would know I'd have 3, 4, because that was one of the ordered pairs that they told me up here. I also know I would have the ordered pair negative 2, negative 6, because I know that when x is negative 2, y is negative 6. So we can, once we have this equation here, we can find ordered pairs that would be on that graph. Okay, so let's do one more together here. Here is my formula that I'm going to use. I know I have y equals negative 4, x equals 5, and so I know I have y equals, I know what y is. Y is negative 4. So I can say, instead of y, I'm going to put negative 4. So I can say negative 4 equals a over x, which is 5. If I multiply both sides by 5, I get a equals negative 20. So my equation is y equals negative 20 over x. Now using this equation, I can find any ordered pairs that I want for x and y. I can give you a value of x and you can tell me what y is. So I know that I want to know what y is when x equals 3. So I'm just going to say y equals negative 20 over 3. So I know that the ordered pair, 3, Negative 20 over 3 is one of my ordered pairs that I would have on my graph. And I also know from up here, the ordered pair 5, negative 4 would also be on my graph. Okay, so what I want you to do is go ahead, there are 3 of them here. I want you to do those exact same steps. I want you to write I want to know what the equation is for each of them with an a value in it, and then I want to know what the y value is when x equals 2. So just like we did on the last 2 examples, I want you just to try that on your own, okay? And again, when you get done, you can check in with Mrs. Kreifels and see if you did it correctly. And then I will begin to unlock the Big Ideas homework assignment for you guys to work on. So thanks for listening and have a great day.